Alright guys, so today we are going to be talking about ratios and proportions. We do have three words for vocabulary. So our first one, what is a ratio? A ratio is a comparison of two numbers by division. And a proportion is when two ratios are equal. A scale, think of a scale as a scale model. A scale model is just a ratio that compares a model to the actual size. It compares a model to the actual size. That's what the scale is. So now what we have here are, over here are 2/3 and 6/9. I'm trying to see if these two ratios, I'm wondering if they're proportionate, and by proportionate, I'm wondering if they're equal. So the one thing that I want to teach you right now, it's called the butterfly method. The butterfly method, well, they call it the butterfly method, well, because when you do this, it kind of looks like a butterfly. So the very first thing that you do, you circle these two, and you multiply. What is 6 times 3? 6 times 3 is 18. Now you circle the next two, and you multiply. 2 times 9 is 18. Is 18 equal to 18? Yes, it is. So, this is a proportion. Now, do you see why we call it the butterfly method? So, we have our wings, and then we have our little antennas. Well, with the antennas, remember, we have to multiply. We multiply 2 and 9. We multiply 3 and 6. If they're equal, they're proportionate. So let's look at the next one. We have 4/5 and 8/10. We're wondering if they are proportionate. So let's do the butterfly method again. So let's do the easier one first. Let's do 4 and 10. We multiply those. That equals 40. Now let's multiply 8 and 5. That equals 40. So are those equal? Yes, they are. So based on this, 4/5 and 8/10 are proportionate. By proportionate, they are equal. Another way that you can use it is called what I like to call it, the multiplication or the division method. It's a little bit shorter than the butterfly method. So let's look at this first one right here. We have 2/3 and 10/15. Are those proportionate? So, one way that we could do it, let's look at the numerators first. How many times does 2 go into 10? 2 goes into 10 5 times. So you would multiply 2 times 5 to get to 10. Now, how many times does 3 go into 15? That also goes into it 5 times. So if these two are exactly the same, if you multiply it times 5 and you multiply it times 5, this basically means you're creating equivalent fractions. But this also means that these two are proportionate. So these are proportionate. Now let's try the one off to the right. We have 3/8 and 12/32. Let's see if those are proportionate. So if we have, how many times does 3 go into 12 if we work with the numerators? 3 goes into 12 4 times. How many times does 8 go into 32? Does that go into it 4 times? Yes, it does. So in this case, this is also a proportionate ratio. Now let's look at the bottom one. We have 81/90, and does that equal 9/10? So the 2 up here, we did multiplication. Now let's see. Now let's try some division. 81 divided by what is equal to 9? So 81 divided by 9 is equal to 9. So is 90 divided by 9, does that equal 10? Yes, it does. So in this case, 81/90ths and 9/10ths are proportionate. Alright, now I want you to try it. I want you to pause the video. Either try the butterfly method or the multiplication division method. Either way is fine. Unpause the video when you're ready to see what I did. Alright, so I personally like the butterfly method just because it's kind of pretty and I like drawing pictures. But, nevertheless, let's try the butterfly method for this first one. We have 6/10ths and we have 2/5. We have two ratios and we're trying to see if they're proportionate. So, let's do the butterfly method for this one. So if we have 10 and 2, remember, we multiply those. So those are 20. Then we multiply 6 and 5. And that's 30. So is 30 equal to 20? No, it is not. Thus, this is not a proportion. Now let's try the one off to the right. We have 1/6 and 5/30ths. And this one, it looks like they kind of look like they might be proportionate. We could do the butterfly method, but I want to do the multiplication and the division method on this one for you. So, how many times 1 times what gets you 5? So 1 times 5 will get you 5. Now in the denominator, is 6 times 5, does that equal 30? Yes, it does. So in this case, these two ratios are proportionate. So now what we're going to do, we are going to use either the butterfly method, or we're actually probably going to use the butterfly method on this one. Now we have a variable. So what we're going to do, we are going to do the butterfly method, but instead of drawing the antennas up top, we're just going to multiply it straight down below. And I'll show you. So we would multiply x times 5, and right there, that is equal to 5x. You bring your equal sign straight down. Now, what is 10 times 3? That's equal to 30. Now, we have our one-step equation here. We have 30 equals 5x. So, 5 times what is equal to 30? What you could do, you could just divide by 5 on both sides. Those cancel. So what's 30 divided by 5? That's equal to 6. So 6 is equal to x. Now let's try it over to the other side, at the problem on the right. Now we have x minus 2 divided by 4, or x minus 2 divided by 14 is equal to 2 divided by 2/7. Now we are trying to solve for x. So let's do the same thing. Multiply. Cross products, we have 7 times x minus 2. Bring down the equal sign. And then we have 14 times 2. That's equal to 28. Now, if we look onto the right side of the equation, we have 7, and then right next to it is parentheses x minus 2. Remember, whenever you see a number with parentheses right next to it, what's the one thing that you know you can do? You could always do the distributive property. So 7 times x is equal to 7x. Bring down the minus sign. 7 times 2 is equal to 14. Now rewrite it. So now we have 28 is equal to 7x minus 14. So from here, what is the opposite of a minus 14? The opposite is to add 14. Add 14 to both sides. So the right side cancels out. Still all that we have on the right side is the 7x. So 28 plus 14 is 42. So 42 is equal to 7x. So 7 times what is equal to 42? In this case, we could divide by 7. And those cancel out. So 6 is equal to x when we have 42 divided by 7, where 6 is equal to x. So now I want you to try. Pause the video, unpause the video when you're ready to see what I have done. Alright, so the first one. Let's see here. We have 6 divided by 12 is equal to x divided by 2. So in this case, we do 6 times 2 is equal to 12. Bring down the equal sign. Then we have 12 times x is equal to 12x. So, 12 times what is equal to 12? In this case, we could still just divide by 12 on both sides. So all we have left on the left side is x. So what's 12 divided by 12? That is 1. So x is equal to 1. Now on the right side, we multiply 10 times x minus 3. And then on the right side, on the left side, we have 6 times 5. That's equal to 30. Remember, we can always do distributive property whenever there's a number right next to parentheses and there's numbers in there. So we do the distributive property of 10 times x, which is 10x. Bring down the subtraction sign. Now what is 10 times 3? That is 30. Sorry, I forgot to add that x in right there. So we have 10x minus 30. So on the left side, we have 30. So now, if we subtracted 30 on the right side, we'll add 30 to both sides, and this will cancel out. So all that we have left on the right side is 10x, and then 30 plus 30 is equal to 60. So 10 times what is equal to 60? So 10 times 6 is equal to 60. So in this case, 6 is equal to x. Alright, so the next two ones that we have are real world problems. So in this case, the Haywood car wash, they washed 128 cars in 3 hours. At that rate, how many cars can they wash in 9 hours? So the important information that we have. 128 cars, 3 hours, 9 hours. So when we are setting up proportions, this is extremely important. So we have our proportions, or we have our ratios that we can create. This first ratio that I want to put all of the information together that pertains to the Haywood car wash. So if we have 128 cars in 3 hours, I could put 128, because these are the cars, are all going to be in the numerator. In the denominator, I'm just going to put the hours. So, with 128 cars, you can do that in 3 hours. So now we are trying to find how many cars can they do in 9 hours. So since the hours are on the bottom, the 9 goes in the bottom as well, in the denominator as well. So we are trying to solve for x. On this case, I'm going to use the multiplication or division method. So how many times does 3 go into 9? 3 times what is equal to 9? So 3 times 3 is equal to 9. So if I multiply by 3 on the bottom, or the denominator, in the numerator, I also have to multiply by 3. So now I have to do 128 times 3 to find for x. So if we do 128 times 3, we have 24, 6, 7, 8. They can do 384 cars. So x is equal to 384 cars. Alright, so now what I want you to do is to pause the video and try this word problem yourself, and unpause the video when you're ready to see what I've done. Alright, so this word problem is an example of scale, because we're talking about maps. So a map is basically just a scaled down model of the way that it actually is. So on a map of Florida, the distance between Jacksonville and Tallahassee is 7.5 centimeters. So if 2 centimeters equals 40 miles, what is the actual distance between the two cities? So let's underline the important information. We have 7.5 centimeters. We have 2 centimeters is equal to 40 miles. So let's see here. We have our two ratios. So one ratio, what do we know that is correct? So we know that 2 centimeters is equal to 40 miles. So what we could do, we could put centimeters up top, and then we could put miles at the bottom. So if we know if 2 centimeters is equal to 40 miles, and we know that on the map the distance between it is 7.5 centimeters. So since the centimeters are in the numerator, we could put 7.5 in the numerator as well. So we are trying to find the distance between Jacksonville and Tallahassee. So that is what we're solving for x. Alright, so in this I'm going to use the cross products. So what is 40 times 7.5? So 40 times 7.5, we have 5 times 0 is 0, 5 times 4 is 20, bring down a 0, 7 times 0 is 0, 7 times 4 is 28, add them all up, 0, 0, 0, carry the 1, 3. So since we have a decimal point, just move it over once. So from here, we'd move it over once. So that would make it 300. So we have 300 on the left side. And on the right side, what is 2 times x? So now we have 300 is equal to 2 times x. So from here, all that we would have to do is divide by 2, and x is equal to 150 miles.